Today we can discuss on the new topic enthalpy and spontaneity. What is meant by spontaneity? Spontaneity means the process when it is occurs without an external agency. Not mentioning that the process wants to be occur suddenly. The rate it's not an important in the case of a spontaneous process. Right? So, what's the relation between this spontaneity and enthalpy we have to be discussed today. Enthalpy, it is an energy. What's the energy change is happening when the chemical reaction is occurs? Mainly two types of chemical reactions we know, endothermic reaction and exothermic reactions. We can discuss one by one and we need to say the enthalpy change in each case first. Afterwards we can tell about that the relationship between the enthalpy and spontaneity. Today we are going to be check with that whether the decrease in enthalpy is a criterion for the spontaneity or not. Is it a compulsory one, the decrease in enthalpy for the spontaneous process? That we are going to be check it here today. Okay, so here let us start with endothermic reactions. Endothermic reactions means you know that it is the delta H value must be the positive value. That is happening in the case of an endothermic reactions. Delta H positive means when A plus B gives C, absorption of heat it is happening in the case of an endothermic reaction. So, how much heat it needs as an enthalpy change, that heat we normally adding on the left hand side. That means for this reaction to occur, we have to be apply here. I took 45 kilojoule per mole we have to be applied, then only A plus B changes to the product of C. But it is the common thing about this endothermic reactions. Okay, we can check about the potential energy diagram of this endothermic reactions. Okay, we know that delta H wants to be positive for an endothermic reactions. So how the way the potential energy diagram will be? Potential energy have to be drawn y-axis and reaction coordinate on the x-axis. Normally the graph we are drawing like this, reactants to products conversion like this. But here the reactant we will draw little down and product is on the up. Why? Always we are taking that the product minus the enthalpy change of product minus reactants as a the criteria for finding the delta H value, right? So what's the value here? You know that when we start from 0, 1, 2, 3, 4, 5 like that, this is 5. Just imagine that this is 10, right? So here product it is 10 and reactant it is 5. So 10 minus 5 what it is? It's a positive value. So likewise we have to be arranged, otherwise the delta H will not be become a positive. So here this is the more value minus less value, it is always a positive value. So delta H should be a positive in this case. So you know that this is the energy in this y-axis now. So which is having the lesser energy is the reactant or product. You know that the lesser energy for this reactants. So reactants prefers the lesser energy. So when you carried out the reactions, almost all the cases we are preferring to attain the minimum energy. That means lowest energy we are preferring. That means minimum energy means most stable situation. So everywhere everyone prefers to get the stable situation. How the way it will be occurring? With the help of minimum energy or minimum enthalpy. So here reactants is having minimum energy compared to that of the product, right? So the reactant formation it is favoring more compared to the product formation in the case of the endothermic reactions generally. But now I will tell about some chemical equations. Here I written two equations. These are the chemical reactions. That means water liquid state to gaseous state it is converting. For that conversion, you know that evaporation of water, for that energy is needed. So they need 44 kilojoule per mole. That means absorption of heat, it is indicated by a positive value. It is considered as a spontaneous reaction. Spontaneous means without any external agency. You know that evaporation, without any external agency, that process it will be occur. Right? It takes little time. If any external agency, that will be occur very fastly. That's only the difference. So this is a spontaneous process, but it is a endothermic reaction. You know that. Right? So we can't say that the minimum energy is a criterion for a spontaneous process. Why? Just before we talk about that, in the case of an endothermic reaction, reactants having the minimum energy. So if that is the situation, this reaction will not be happen. But this reaction, it is happening here. From that you can identify that the minimum energy is not a criterion for this spontaneous process. Here also, sir, water in the solid state to liquid state conversion. Here also, you know that ice, it changes to liquid with a little energy, without any external agency. The process it will be occur. That is a spontaneous process. When you check about that, you can understand it very clearly the same. But you know that this is a positive value. Just before we studied that, in the case of an endothermic reaction, minimum energy is only in the case of this reactants. Right? So endothermic reactions, most probably it is preferring to get the minimum energy. That's why the reactant formation, it is happening more. Likewise we said. But that is not applicable in all the cases. Why? Most of the endothermic reaction, it is occurring without any initiation. That means that is a spontaneous process. So that minimum energy is not a criterion for a spontaneous process. Now, just to think about that exothermic reaction. Exothermic reaction, you know that delta H, it wants to be negative value. So how it is possible? This is the way of arranging reactant here. This is the product here. As we know that how the way delta H, we are finding product minus reactant. The energy of the product minus reactant. So this is having the lesser value. This is having higher value. So lesser value minus 5 minus 10. What's the thing? It will be a negative value. So likewise the energy profile diagram for this exothermic reactions. Exothermic reactions, as you know, the delta H value, it is a negative thing. Okay, so here, which is having the minimum energy, product, it is having the minimum energy compared to that of the reactants. So it is always, when you carry out a reaction, if it is an exothermic reaction, it surely favor the product formation. Okay, because always the chemical reactions, they are preferring to get the minimum energy and minimum enthalpy. That means most stable situation. So just imagine this equation, C plus O2 gives CO2, the delta H value, it is a negative value minus 39.35 is the value. So this is spontaneous because of the decrease in energy. Okay, so that is the main difference between the exothermic and endothermic reaction. In both cases, we discussed that the spontaneity. Normally, we are favoring minimum energy situation, more getting the more stable situation. When we correlate that energy with spontaneity, the decrease in energy or minimum energy, it's not a criterion for spontaneous. Because from some of the examples we understood that if there is a positive the delta H value, if there is an endothermic the reaction, if there is a more energy that situation, then also the process it is spontaneous. As per theory, delta H is positive in the endothermic situation, but we know that endothermic delta H positive means there is a minimum energy for reactants, not for the product. Then also the product formation it is occurring. That means the minimum energy is not a criterion for a spontaneous process. Okay, thank you.